Imagine a computer chip that doesn't use electricity, but light, tiny particles called photons. That's the promise of quantum photonic chips. Unlike traditional chips, these harness the strange rules of quantum physics, letting them process information in ways today's computers simply can't. The secret? Quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to a property called superposition. Photonic chips use light to create and control these qubits, making them fast, stable, and perfect for ultra-secure communication. This could mean computers that design new medicines, materials, or even create an unhackable internet. The challenge now is moving from single, hand-built prototypes to mass production, making millions of these chips reliably and affordably. This shift will transform quantum technology from a scientific curiosity into a world-changing industry. It's a massive undertaking, but the potential rewards, faster computers, secure networks, and new scientific breakthroughs are immense. Quantum photonic chips are set to redefine how we use and protect information. Turning a quantum photonic chip from a lab prototype into a real product starts with a design, mapping out how light will travel and create quantum states. After computer simulations, the first chip is built in a clean room, proving the concept works. Next comes rigorous testing and refinement, tweaking the design until it's robust and reliable. The real challenge is scaling up. What works for one chip in a lab must be automated for thousands in a factory. Engineers develop precise manufacturing recipes, ensuring every chip meets strict standards. Beyond making the chip, companies must consider packaging, integration, and how the chip will connect to other devices. Building a supply chain and preparing for market use are just as critical as the science. This journey demands collaboration between scientists, engineers, and business leaders. Only by working together can we bring quantum technology out of the lab and into the world. The path from idea to product is complex, but it's how quantum chips will reach everyone. Mass-producing quantum photonic chips is a huge challenge, requiring ultra-clean foundries and advanced automation. Processes that once took days in a lab must be completed in minutes, without sacrificing quality. Even microscopic imperfections can ruin a chip, so factories use real-time monitoring to catch and correct errors instantly. Many chips combine multiple materials like silicon and thin-film lithium niobate, which must be fused together flawlessly. Aligning these materials at the atomic level is a major engineering feat. High yield, getting most chips on a wafer to work perfectly, is essential for commercial success. In research, a few working chips are enough, but industry needs nearly every chip to be flawless. Foundries are constantly improving processes to boost yield and reliability. Hybrid integration and process control are at the heart of this new industrial science. The goal: turn quantum chip making from an art into a repeatable, scalable technology. Only then can quantum photonic chips power the next wave of innovation. The race is on to make quantum chips as common as silicon ones. Building the chip is just the start. Packaging is where quantum technology meets the real world. Quantum chips are fragile. Their delicate states can be destroyed by heat, vibration, or stray light. Packaging must shield the chip while allowing perfect optical connections, aligning fibers thinner than a hair with nanometer precision. Heat management is critical, as even small temperature changes can disrupt performance. The package also integrates classical electronics, placing control chips as close as possible to minimize delays. Co-packaging quantum and classical components is a major engineering challenge. Automation is key. Robots must handle alignment and assembly at scale, making packaging fast and reliable. Scalable packaging is as important as chip manufacturing for bringing quantum devices to market. Without robust, affordable packaging, even the best chips can't leave the lab. Packaging is the bridge from quantum science to real-world impact. For quantum chips to matter, they must connect to each other and to classical computers. Building powerful quantum systems means networking hundreds or thousands of chips with ultra-fast, lossless optical links. Every lost photon is lost data, so these connections must be nearly perfect. Standardized optical interfaces are being developed to let chips from different makers work together. Quantum chips will also work alongside AI and classical processors in hybrid systems, each handling the tasks they do best. Seamless hardware and software bridges are needed to move data between quantum and classical worlds. New programming tools will let developers use quantum power without needing a physics degree. Making quantum technology accessible and easy to integrate is essential for its adoption. The future of computing is hybrid, and quantum photonic chips are the key. Connecting these chips unlocks their true potential. The race to commercialize quantum photonic chips is on, with billions invested in new factories worldwide. Companies and governments are shifting from research to mass production, creating new jobs and tech hubs. In Arizona, Quantum Computing Inc. opened a state-of-the-art foundry specializing in thin-film lithium niobate chips. This facility marks a milestone, building a domestic supply chain and accelerating U.S. innovation. Globally, companies in Germany, Switzerland, and beyond are scaling up their own quantum chip manufacturing. Startups are raising capital to advance new materials and processes. This global competition is driving rapid progress and building a diverse ecosystem of suppliers and experts. The market for quantum components is set to explode in the coming years. Early foundries are already fulfilling orders for data centers, telecom, and advanced sensors. We're witnessing the birth of a new industrial revolution powered by quantum light. Solving the challenges of quantum chip manufacturing and integration will unlock a new era of technology. Quantum computers will solve problems in minutes that stump today's supercomputers, revolutionizing medicine, materials, and more. Quantum chips will also secure our communications, making data breaches a thing of the past. The quantum internet will protect sensitive information for governments, banks, and individuals. This technology is already creating high-tech jobs and new economic hubs. As quantum chips become widely available, they'll enable businesses and services we can't yet imagine. The journey from lab to market is tough, but global investment and collaboration are making it real. Soon, quantum photonic chips will power faster computers, safer networks, and new scientific discoveries. The microscopic dance of light on these chips is set to transform our world. The future of technology is quantum, and it's closer than you think.